Donald Chewy. How is everyone doing? Today I have 3 things that I'm planning on doing, and then after I get done with the game dev, I'm gonna play some more Death Stranding. But I didn't do any game dev yesterday, so I need to do some today. Actually, there are 4 things. We need to have a retrospective. I'm just putting that on my list of things to do. That actually kind of sounds the most fun, but I should leave it for the end when I'm done with the other things I'm going to do today. But today I'm going to talk a little bit about the high-level view of how I structure a game. So I'll be in GIMP and illustrating things as I talk, and then we'll get into some coding. I need to make the map and export it, and then we'll work on loading it in the game and the things related to that. So,
Okay, so let's talk a bit about how a game is structured. So if you're at all familiar with making software or making web pages, those are different ways. So let's say if we just had a piece of software where you had buttons and it did some stuff, it would just sit here and wait, and when you click on a button, it would actually call a function to do something. So this is more event driven. Like unless there's something going on at the same time, like let's say this is a random video player, so a video is playing right here, and that does its thing while it's running, but then it just kind of waits for you to press a button to do any changes, to make any updates. That's not what game development is like. So when you have your game, the game is going to continue running, whether or not usually you're doing anything. Even with a turn-based game, stuff will still be animating. There could be other little things happening, but the game is going to continue running. So if you think of like Mario and you have like enemies that'll go back and forth while you're walking, rings will kind of spin around. Things will keep happening. So the world continues. It's not just waiting for you to do something. So this means we need a game loop. Also with programming, if you've ever written a simple program before, when you start running the program, it runs through the code, and once it hits the end, if you don't have any loops in there, it will exit immediately. So this is good for scripts if you needed to do a task really fast and then exit, but that's not what we want for a game. We don't want it to exit until the user actually tells us to exit. So with the game loop, the basic idea is that we're going to initialize the game. So that means just setting everything up, whether that's like initializing variables if you need it, or setting up different managers, or calling the library setup function so we have SFML ready to go, and then we enter into a game loop. So in the game loop, we will basically always loop, and it'll have some sort of delay based on the frames per second, but I like to think of it as check for input from the player, respond to that, do updates. So that could be like, hey Goomba, move to the left or something. Like the player's going to have updates, the enemies are going to have updates, items might have updates. If you have a game timer, that might update, and so on. And then finally you draw. So you draw everything to the screen. The input, maybe it's exit or something like that, and so at that point you would have a cleanup. So input, this could be keyboard input, mouse input, just kind of detecting if the player is doing anything in the world. And for example, let's say they've hit the right mouse or the right arrow key, and let's say they move with a velocity. We're not going to do this for this game, but let's just say their velocity is now 10. So that doesn't necessarily move them right away. We're just saying their velocity is 10 in that direction or whatever. Then in the update phase, we would actually move them, this weird right, sideways. We would actually move them by that velocity. So the input phase updated the velocity. The update, sorry, input phase? Is that what I said? Input phase updated the velocity. Then the update phase changes the game state based on that. So update, that will be, and really these two can kind of go together. It depends on what the library is like. Since with SFML, I don't have to have like a separate keyboard object doing a bunch of pinging and then sending data to the other thing, this will actually be more together because I can literally make a player update function and inside of that check for the keyboard data. Whereas if I were using a different library, I might have to do that detecting keyboard presses ahead of time and pass that to the player to update things. So we'll have stuff like the player will update, and that could be their movement. It could also be, like, let's say the player got poisoned and then there's a timer running down on how long they're poisoned. That would be handled in update. Maybe they, we'll see things. I'm trying to think of what will be in the game. For the most part, we'll just handle moving around with the player and then also checking input to see if they're attacking. So those will be the main things. We'll also have enemy updates. So each enemy will also update, and usually that will be like, where does that enemy want to move based on its behavior? Does it chase the player? Does it chase the treasure? Does it randomly move? Does it follow a set path? So that's where its behavior will be decided and that will be updated. And we could have a map update depending on what we need. I know in Venture there were those moving walls. I'm not really going to do that, I don't think. I would just make those enemies, actually. I wouldn't make those part of the map, but if we need a map update, we can do that. And anything else. So another thing would be, at this point when we're updating things, we'd also check the collision. So is the player hitting an enemy? Is the player hitting the treasure? So I'll just put item. And also, before we move the player and before the enemy moves, is there going to be a collision between a player and something solid in the map? If no, then you can let the player move in the direction they were intending to move. If yes, then you can only move as far as you can until you hit that wall, and don't let them continue going past that. What else do I have written here? We might have projectiles. So with a projectile, we'll have like a direction it's moving and a speed it moves at. So every time, that's not in the collision. Well, we'll check projectile against enemy. But we'll have projectile update. So as it's moving, it will say, okay, we're at this position, we have this speed, we're going to update it by this amount. Are you hitting the map? I don't know. If it hits the map, maybe it just goes away. Are you hitting an enemy? Kill the enemy. So we have all of these things to check on. Yeah, and then drawing, that will just be call the player's draw function. Call the draw function for all of the enemies. Call the map's draw function, which will handle drawing the tiles. Draw the projectiles. Call the projectiles draw function, and all of that. Also, in the update, I just want to mention that if we have like an enemy, we have enemy, player, and projectile, and those are the main things. Sometimes, to make a decision on what it's doing in that update, it needs to have access to another entity. So on its own, by itself, enemy only knows about its own instances, X, Y with height, whatever. If it's going to chase the player, we're going to need to provide the player information to the enemy. So for example, maybe the update, maybe it'll have a reference to the player. So you can access the player position to move towards that direction. Or maybe there will be something like a set goal function where we pass in the player or we pass in the treasure or something like that. Let me also put, we have items, treasure items. So sometimes you'll just have to pass that data over. Now all of these are going to inherit from each other, not from each other. Sorry. We're going to have a base object, and everything will inherit from these. So we'll have items, tiles, projectiles, enemies, players. This is not quite the family tree I'm going to use. I can draw this a little bit nicer. We'll have the base object. This is at least how I usually do it. The base object will have X and Y, width and height, and maybe that's all the information needed at that very basic level. So the item might inherit just straight from the base object. If it isn't an item that moves, it just has an image. The image, it has a picture and it has a place where it's sitting, and it sits there. Then we might have a character class. So usually in a character, I put in a animation functionality, so we'll go over that when we get to it. Collision, well, this is just going to be a bounding box. We might put collision info. We'll see. Collision info. Movement. Health, maybe. Of course, in this one, it'll be like everyone has 1 health point, and if it gets hit, then you die. And then from there, we'd have player, who specifically uses like keyboard input. And we'd have enemy, who uses their AI to make decisions on how to move. And then also item and tile can really kind of be the same thing, where it has a collision rectangle, it has an image, X, Y with height, and all of that. So this is all to say that because we have this parent object that's common to everything, if the enemy has a set goal function, we can just pass in a base object. It doesn't need to know if it's a player specifically or an item. It just needs to know it's a base object that has X, Y, width, and height. And so when the enemy has a new goal, X and Y, to go to, it just needs to know it's a base object. Likewise with collision. At least for we're going to have 2 types of collision from what I'm currently thinking. But let's say our bounding box collision, that can just take in 2 base objects and then check their X, Y, width, and height against each other to see if they're colliding. And then that way we don't have to write new collision functions for each type of item. Let's see, what else do I have written down? Okay, let's cut that. So in the wider game itself, this game loop mostly, there'll be loops in the entire thing, but this will be mostly the game state here. But the main program in main, this one actually has the game loop and it calls game state update, game state draw for us. But for the program itself, it'll have initializing, which is mostly going to be SFML and the managers. Get them ready to go, read the config and whatever. Updates. It'll take care of the state, so it'll set up the next state and call the state update and draw through the state manager. It'll also be responsible for changing the state. So if a state's go to state parameter is set to something besides an empty string, then it'll say, oh, now we're going to change this state and make it a different state. So we call the state init, and then it becomes the thing that gets called in the update and draw. And maybe we need to communicate some information between the different states. So the state itself, if you think of like just writing a really simple program and you have everything in main, like all of the game logic in main, we're kind of doing that, but putting that stuff into the state to make it cleaner. So we have a state manager to handle changing between states. And if we need data to be passed between states, maybe there'll be like a messaging, not like a formal messaging queue type of thing, just kind of like a store, like a global store. It's a static class or something. You can store some data by key and data. So for instance, like in previous games I've did, maybe you're at the menu, like the level select screen, and you click on, oh, I want to play level 5. So maybe I'll put that in the global store, change to the game state. It will check what level to load based on that global data, and then load it up, and then we don't have to do anything special for each level. It just knows which one to load. Okay, so hopefully that wasn't too confusing. Hopefully you at least got the idea of the game loop and then just everything that has to be done in those. And then we'll be doing the coding, and you'll kind of see that from the in-depth point of view. But I just wanted to state that in our game state, we have updates that happen. We have input, updates, and drawing. And drawing is easy. The updates are going to be the big thing of handling movement, collision, and anything else that happens to be needed. So let's build our map, export it, take a look at that map data, and then get started on loading it into our game. Okay, while I'm thinking about it, so there are different ways we can handle collision with these maps as well. Let me also just open a little thing to draw in. I usually like to do it where I have a specified like collision tile to specify you can't walk there. So I'll do that really quick. We'll just... I usually like to make it the top right so I can find it easy. We'll just, I guess, make this the collision tile right here. Are we not on the grid? Okay, so to do that, we will set this here. And now we have this. So I'm going to make a collision layer. And really, it doesn't necessarily have to be this X. I just think it's more helpful for us humans to see it. This could literally be like, if there's anything on this layer, don't allow collision with it. But it'll be more human readable if it's like this. So I usually like doing this sort of thing because that means I could make like secret walk through walls and stuff. The other way we could do it is if we just say, hey, any set of bricks are solid, don't move through bricks. So we could do it either way and then just have like a special like pass through brick It's like a secret, you know, that we show. So for instance, maybe we wanted to specifically allow certain brick types. We'll just make it up here. This is the secret pass-through brick. We'll make it a tiny bit lighter. There, and we'll save this. So this is the secret pass-through brick. So if we were, let's get rid of that. Making this so you could go through this wall. This one's a little bit lighter, and then I guess we'd have like a secret pass-through ceiling also. Then you could see that in the game, or I could make it like very solid colored and the same color and just say this is the pass-through version, this is the solid version. And then you could go through there to find a secret. But I tend to like doing it with the collision layer like that, and just saying you can't move through any of these, yay, or you can't move into these candlesticks. The only thing that's annoying is I would need like maybe a half collision for these, which we can kind of draw in, or we can just say they can't step in any of this square space, but that doesn't really make a lot of sense. So let's do that really quick. I might also make this less opaque. Whereas this is... I think I put that on the ceiling layer. We'll put this on a collision layer, and we'll make that like half transparency. And we'll make a version that maybe specifies that you can't go this way. Let's see, I don't want that entire thing, I just want to do something like that. So we'll do a few of these for each direction. And we'll save that. So then in the game code I could say, oh, which type of collision is this? This is like a diagonal type of collision. Yeah, and kind of just handle it that way. So, just gotta color in all these collision areas. And then we could also just hide it on this layer if we wanted to see what it looked like without it. I'm gonna put these in here. Accidentally did that, that doesn't matter. And down here, well, actually, he's not going to move in there at all. And over here. So then there's our collision information. And this one's not going to have like a secret pass-through. I suppose if I put like a wall right here, I could make it so you could pass through because it's like a wall and you see the ceiling and there's a separator, but maybe there's a door in between, but whatever, we'll just do this. This is our test map. I'm going to delete that because that's not going to be part of the map. I guess I could also make this just different types of properties, like if I wanted this to, like carpet to slow you down or something, but we're not going to do that. Then we need to export, and I will put this somewhere in there later, but let's... We need a content folder. Oops, that is not what I meant to do. We're in here, content, maps. So this is just, let's just say this is room dot, and they can export to a Lua file, a JSON file, a tiled map file, CSV. Right now this game doesn't have any Lua in it, So let's see what the CSV file looks like, and we might have to write something to parse it ourselves, which we will do. It will be fine. Content maps. Whoa, what? Oh, it put all of the different layers in their own CSV file. So this is, yeah, you can, I mean, you can kind of see what's going on there. There's the collision, and then there are the ceiling tiles, some of the decor, the ground is all over. There's the carpet. There's some shadows. There are the walls. So this is a lot like how I made maps when I first began programming, and I literally would just make a big grid like that. That is not my favorite. We are going to possibly export that to something else. I have also written a map converter. I don't know if it's in my bit bucket. We'll see. Because I don't really like the tiled map style. Okay, let me check my GitLab. Maybe it's in my GitLab. I might have to write a new converter if I don't like it, or I can just try to parse it. We'll see. That is not GitLab. This is GitLab. I don't think I put it in here. Yeah. I used to just have a converter that would convert from like the Lua output to something I liked more. Let's just look at all of the styles. Let's look at Lua. Let's look at JSON. Let's look at tiled. So if we had a tiled map, that gives us some XML with all of the layers in a grid like that. If we look at the Lua, that's also going to give us that, but it'll have this data ahead of it. JSON, oh, that's nice, whatever. So I guess I took like the Lua scripts and made them into a format that I liked better. Now I could just write a parser to parse this. That's kind of less desirable because I don't want to have to deal with the curly brackets. I'm just trying to think of what the best way to do this is. Because in C++, like, it's a lot easier to parse and just like skip over white space here and there and kind of deal with labels than it is to do it this way. So I could write another converter, but it will also take part of the day. And then also, I don't really like having my data in just a grid. So when I first started programming games, I'd, make my maps like this, and then say like, oh, here's the ground. Here's some obstacle, and so on. And I would make my maps like that. But now I actually prefer to make my maps more like, here's tile, maybe if I'm going to make it easy to parse, tile begin. X position is at blah. Y position is at blah. Image code is 10, which the image code here is like 145, or 0 for nothing, 163 for a floor or carpet or something. And then maybe I could put that collision is true or something like that. And then tile end. And then that would be really easy to parse in C++. You just kind of loop through that. And then, we could also have like a Z coordinate instead of having all these separate grids here. We could just have one big list of tiles and then have a Z coordinate for which position things are going to be in. Because we need to have the ceiling above the walls, otherwise that's not going to look right. You're going to need the shadows above the floor, otherwise that's not going to look right. and all of that. So, or I could just go write my own map editor, but that would be a big waste of time. Thinking, we might just pull out the Lua and make it ourselves, or if we try to parse the JSON file, I could do PHP, I guess, or something. The thing is, like, I haven't used Lua in a while, so I'd just be like fumbling around with the syntax and stuff, trying to get it right. Does Python have a JSON reader? Maybe I can do that. Python JSON. I'm pretty sure it does. Maybe we'll write a converter in Python. That might be what I do. And we'll have to write... Okay. Well, I really want to write a converter, and I'll put it on GitLab, and I'm going to record it, but I'm going to just fast forward through all of it because I don't really want to go into the specifics. I'm basically just going to read the data, and then I'm going to output the data again, but in a format that I like. So it's going to be a lot of code that's kind of ugly, and the logic itself is just read the data and then output it again, but just in a different way. So I don't feel like really explaining all of that. And then we'll go in and load the map files. So I guess that's what I'll do next. Okay, I have converted the map file. So there's a load, which is easy to use. There's a convert, and then there is a output data. So if you wanted to modify this for your own use, it should be relatively easy to do so. I'm just going to commit this. So basically we go from this format, which would be kind of a pain to parse in C++. All of the data is here, and it has information. Here's height, and then here's the rest of the map data. It loads that into just an object, like a dictionary in Python, and a list for the tiles, and then it outputs it in this format. So this will be a lot easier to parse in C++, just because of the white space. And it's also in the format where each tile has its own set of data. The z-coordinate is basically just corresponds to which layer it was on, but I also put in the layer floors, like the text information about it. I did have to go back and change these to not have spaces, because that would also kind of just mess up my parsing, but that should be good, and we can load in that map data, yay! And if you want to use that, that is now also up in my GitLab under Personal Projects. There it is, the tiled map converter. Yay! It is a short intermission time. I would like some snacks. Have you had a glass of water recently? It is important to stay hydrated, so I hope you've been drinking water. Don't be like Sam Porter Bridges, only drinking Monster. Drink water. Have a nice cup of water right now. Hello! Now we're gonna do maps. So, first off we have a game object. This is not all the stuff that will be in it. This stuff will belong in a character, but I do need to make a child version of the base object that has the tile image information. So, let's start by changing this up a little bit. We'll go ahead and make a character object, and we'll make that tile object. So I'm just going to move some stuff over to kind of get everything ready. All game objects are going to have a texture associated with them, and I'm making this a reference because we don't want to make copies of the texture. We don't want to have, every tile is going to use the same tile set, we don't want to copy that tile set a billion times. So it's just referencing the textures. The texture will be handled in a texture manager. I'm also creating a texture coordinates value, which will be pointing to where on a sprite sheet or tile map the image will be used. So, you know, we'd have to say, oh, at X location 0, Y location 192, we're taking this with 32, 32, and using just this section for a specific wall tile. I might have to turn this into a pointer for now again, and also again follow up on pointer stuff. Make it into a newer pointer, just because I'm not sure if like, the reference has to be set. You can't really, like, change the reference after the fact. But with a pointer, you can set it to null. Actually, I might not even need this to store the texture, because in SFML it stores a texture object, which is the image, and then the sprite is a smaller thing, like separate, but references the textures. So I don't think I need to do that. I think I just need to reference that and then use this dot set texture. So that makes it a little easier on me. Okay, I don't know if the tile will really need more information than what the game object already offers, but here we have a tile. We can expand on that as needed. I'm going to, in the game state, get rid of these objects here, because we're not gonna be testing with those. So we're just gonna look at the map stuff. Okay. Now we need to make a map that stores all of the tiles. So, what should we put that under? Nope, code blocks is glitching out again. Gotta close, gotta reopen. Okay, so some of the things we will need for the map, just some basic information like the map width will load in, map height. I don't know if we really need the tile width and height, because yeah, I don't really think we need that. And then we're going to need that list of tiles. Now, they have different z coordinates, and I want them to be drawn in a certain order, but I'm trying to think here. They're in an order where the zeros will be drawn first anyway, so I'm wondering whether it's fine to just put them all in the same list, except the ceiling tile. If we happen to have any art that will go above the player, such as if you, let's say the wall is, I don't know, let's say you just had somewhere where you were walking under the ceiling and had to get through, and it's fine, you can go through here. We would want that to show over the player's sprite, so that's usually you'll have like the stuff that renders below, the stuff that renders above, or at least that's what I usually do. So let me just use the vector library, and we will have a vector of tiles for under and over. Okay, and we will need a function to load the map. So let's, really that doesn't, I'm trying to think. Yeah, let's say load map. Have to include some string, and in other programs I've done, I've written something where it knows the path automatically of where to find maps. I'm trying to think, that could just be in config file or something, but I don't usually like passing the whole path. It doesn't matter that much right now, we're just doing this. So let's go ahead and create void map, load map, and we're going to also need a draw if we want to draw the stuff to the screen. So void draw, We need that. Tiles already have a draw, but we need the render window to pass around. And now we can load the map. So we'll just use our standard input-output stuff with C++. So we need the fstream library. While we're doing this, let's go ahead and tell this to load, that it will be loading a map. So map. Oh, nope, lowercase. And then in initialize, we will load a map, and we'll pass it content maps and room.moo. And we will go ahead and also call the draw function down here with the window. And as we're working on it, we can keep trying to test it out here and there. So, loading the map, we need to create an input file stream, pass in that file name, and usually I'll make like a buffer string. These need to be from the std library. And what I do is while in file can read into buffer, so it'll only it'll stop at the white space and read one thing at a time, and then based on that we can figure out how to parse it. So just while we're testing, I'm going to put in iostream so we could show you what it's reading in. So cout, what's in the buffer. So let's see if we run this now. Okay, game state. Is this the maps folder? So that's there, but we can see here it's outputting all of the data that it was loading. So here's a bunch of tile data. So let's close that. We know it's reading in information. So I tend to use code blocks does things sometimes, and I should just be using Spacemax, but I don't know. I would have to take some time to get things set up how I want it. Okay, loading in the map. Open the map. Oh, the annoying thing is also that CodeBlocks doesn't automatically save the file I put in here. Add file, maps. We're adding this map, okay? Now save the project. Okay. So if buffer is map width, then we're going to load that the next thing from the input file as the map width. So in file, store the map width. This is going to be a little long, so we could kind of try to make things a little bit more concise. If buffer is map height, then we're going to store into map height, so it will at least parse those in there. I don't really care about tile width and height. We don't have to write an if statement for those. It'll just pass over those if it doesn't meet any of these if criterias. Then, we don't really care about tile begin. We could use that to kind of clear out information we're storing. So let's just say if buffer is tile begin, these need to be in double quotes also. These are not enums. If that, then we're starting to load a new map. We're going to need to keep track of the X and Y. We don't really need the Z coordinate. I guess it wouldn't hurt to store it. But then I'd have to add it to the game object, whatever. I'll just do this for now. Image code. I don't know if we need layer name. Did I put that in our tile? I put tile type. Okay. So we're beginning this. Let's just initialize everything to like -1s. We really don't have to do this step, but sometimes it can be helpful just to make sure everything is starting from a clean slate, if in case for some reason some data is missing, which it shouldn't be. Tile type name is empty string, and if the buffer is tile end, then we know we can save this data. So at the end here, then we're going to save what was stored in those holder variables here. Otherwise, we're going to be checking for buffer equaling capital X. Then really all we do is X, store whatever the next in-file item is into X. So indent those little. If it's Y, we're storing it into Y. If it's W, we're storing it into W, and so on. So, starting a tile, save the tile to the list of tiles. So then we need to make a new tile. Pull that over here. And we're just gonna set up all that information. So tile.setup, it's X coordinate, it's Y coordinate, those are from the temporary variables. It needs a name. Let's give it a name. I'm going to make a counter as well. And something else I'm going to have to put in here, something to convert an int to a string, or a string to an int. I don't know, we'll cross that when we get there. Tile, well, yeah, we need it here because we need to change tile to plus counter, and we can't just do this in C++. They don't make it super easy. So I wonder if I have this in my GitLab or in my GitHub, or not my GitHub, my Bitbucket. But I had a bunch of C++ utilities that I always reuse. Also, it's in Kuko. I could just grab it out of Kuko. Utilities. Let's just pull these utilities down while we're at it. So I'm going to make a utilities folder. Okay, so let's step through these really quick, just so I'm not like skipping a step and leaving everyone in the dark. We have my lovely logger now that we can use. I don't have to rewrite this entire thing. So it stores logs from the program in a HTML file, so it builds out the HTML for me and it makes it easier to read. Close this stuff. I have this is just my global pass things between states thing. It's really just a dictionary that you store data in. Platform, this just tries to get the operating system that it thinks you're running, and it also has something to open the URL, like if you click on the social media icon, it'll try to open that up. And then my string utility, which could rename these to be a little bit more short, but excuse me. I have something to get a nice looking time for the string. I have something to remove white space. And then this is to get like an address from a pointer, integer, change a float to a string, and all that. So we'll just go ahead and add those from here. I don't think it has anything in there that needs SDL, which is what Kuko is written in. I think it's all pretty much standalone, but now I can also use this cool logger. But we have string util as well. So we're setting the name from tile to, tile number 0, tile number 1, and so on. So I could do some type defs or just rename these. It's not that important. Let's just do I to S for int to string, float to string, heat to string. I don't know if I'll need that. String to int. That'll make it a little bit shorter. And also, these are all static functions as well. Stir. We'll just name it stir. Just to make everything short. I know I could do a type def. I don't feel like it. I'm not a big fan of just giving things alternative names, I guess. So, string, int to string, the counter. And I also need to make sure I include that up here. So include from the utilities, let's include the logger also, and the string util. So cool. Let's open up the logger. I know I'm like kind of going off on a tangent. We're not going to use the logger right now. We'll do that later because it requires a little bit of setup. Okay, so name that tile that. We also need to set its image and the code. So if tile type name, and let's look at what these are again. Tile type name dot find, the text collision is not equal to, what was it, string in POS, no position. Basically, I should make a utility function for that too. Let's do that really quick, because this is ugly. Static bool is let's use string contains const string haystack const string needle. Put that. So take the CPP file, make that down here. And we just return whether the haystack dot find needle, if it is not equal to string no position, then it exists. If it's equal to string no position, then it doesn't exist. So okay. If tile type name dot contain dot string contains this and collision, then we're going to call tile type is equal to collision else if it includes got floor, shadow, wall, decor, if it contains the text ceiling, and so on. So okay, and we don't have setting up the tiles graphic yet because we haven't loaded the tile set texture. So we'll do that here in a second. I just want to add this to the list. So if the type is ceiling, then it's going to go in the over tiles list, and if not, it'll go in the under tiles list. So this dot push back our new tile, otherwise over tiles. Alright, so that does not build because the logger uses string util. Good. Great. Let's replace string util with str. Replace. Yes. Let's see if it builds. Oh. Okay, now if we want to have the texture, I'd rather just go ahead and make our texture class and our texture manager so that we can have all of the textures stored in one area and then just pass references where they are needed. So we're gonna work on a new manager. Okay, so for this texture manager, I've made the HPP file and the CPP file. This is because with managers, they can be used throughout the entire program. I generally make all of their members static. And to do that in C++, it requires you to do this and just put that variable over here for some reason. I don't remember the exact reason for that. C++ is kind of weird. But yeah, so we're going to make all these static. Yay. And the map is going to be utilizing the manager. So include managers, texture manager. So it will access it to get textures. Okay, so within the texture manager, we'll have an add texture function. We could also have something like clear textures. So if we wanted to like clear out all textures when a game state ends, and then add new ones when the game state, a different game state starts, then we can clear out that memory. So here, when we want to add a texture, we're going to create an SF texture. And we're going to load, if not texture dot load from file. A path is supposed to be passed in, and this is an error if that doesn't work. If it does work, let's just say we'll return. We could throw an exception, but for now we're just return. There's, you know, always stuff you can clean up. And then in the M textures map, we're gonna set the item at that key that's passed in to this texture that we've made. Now, I'm trying to think. This should just copy that, right? This is also one of the tricky parts of C++. If I made this a reference, this would not work because this is a local variable. It's allocated on the stack. And if this were a texture reference, it would basically be referencing nothing once this left. If it were a pointer, I would have to make this dynamically allocate that memory for the texture. I think that since these are just going to be on the stack, I don't think this will cause any memory problems. It's going to allocate memory on the stack and then copy it here, I hope. I hope the copy works for textures in the SFML. And then I think it should be good, and then we can just get stuff back. And then I'm not sure how to clear the map. Is it just clear? We'll see. And then we'll want something like SF texture with a reference, get texture, and to get it you'll have to pass in the key. So down here. And we can also add error checking to see, like, did you pass in the wrong key? Does that key even exist in the map? But for now, we are going to pretend that I don't make any errors ever, and we are going to return that reference. So let's see if this builds, and we're going to set things up. Okay, since we're working with a static class anyway, I'm going to go ahead and initialize the logger inside of main, so we can just use it. Include utilities logger. So the logger needs to be set up before we can use it, even though it's static. So we have set that one up first. It's important. So logger setup. I could pass in a log level. Don't need that. I just turned off my monitor. Okay, and at the end of the program, I have clean up. So once the program is done, logger clean up, that closes the that finishes writing what it needs to the log file, and then closes it. So in our texture manager, if something goes wrong, we can say logger error, unable to load texture at path. And we can just copy that in. And I like to put in the location, so I'll just usually add this sort of thing. Okay. Now, I feel like maybe it's getting a little confusing now, but just bear with me for a minute. In the game state, I'm going to add our tile set. So include the texture manager. I'm going to need to move that tile set somewhere because I don't think it's currently in here. We need a graphics folder. I just kind of have the tile set sitting here as tile set test. I like keeping things as clean as possible. That I did not mean to cut. I meant to copy. We'll just name this tile set. Okay, and inside of our game state initialization, we will need to call texture manager, add texture, tile set, and we'll give it that path. So it's going to be content, graphics, tile sets, tileset.ping. Okay, so that should load that in. We can also add logging in the texture manager anytime that happens. Since this isn't something that happens every cycle, it's just the one-off thing, I like to add logs in this case. So just output that we're adding texture with key to path and location. So we'll pass this over here. I wonder if the error messages in C++ have been changed in more recent versions, because I feel like I'm not recognizing the error messages as much as I used to. But maybe they just changed how errors are. Oh, did I not make that static? It needs to be static, that's why. It's saying that it needs a member, or for a member function, it needs to have the object initialized or instantiated. And I don't want to do that, I just want it to be static. Okay, let's run it. It should load the texture and then really not do anything else. Close that window, close that window. Now, if we go into the project path, we'll have a log file, and it looks like this. So it added that texture, it didn't give an error, and then the program closed. So I also will need to add log.html. Don't save that in the source control. Okay, so where were we? We were loading in our maps. So I'm just going to store this in a reference here so we don't have to keep calling texture manager get texture. All of these tiles are going to have the same texture. So tile.set texture, and then we need its coordinates. So we'll need to make an int rect. And that's going to correspond to where it is in the tile set. So the coordinates in here. And we find that out based on the image. This is another annoying thing. I could have added this into the converter. So tiled. I should have added this into the converter. I believe that tiled will go like 0, 1, 2, 3, 4, 5, 6, blah 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 blah, and it'll just keep track of a linear number instead of an XY coordinate. So I need to know what the width of the tile set is to calculate the actual X and Y coordinate on that thing. And let's look at what this exports again real quick, because I might need to go back and add some more information. Okay, I'm not seeing the information about the tile set and how wide it is. I'm sure it's being stored, because it asks me every time I reload this thing. Okay. So for the time being, I think we're gonna hard code some shit. Or really, we can pull the width and height of that tile set from the texture information or something. So we'll just do this the more annoying way. Let me look in the documentation on how to get the dimensions of an image. Okay. So tile set width is going to be texture, well, actually this is going to be a vector. SF vector 2u, tile set dimensions is our texture.getSize. So that will be this width, this height. We know our tiles are all going to be 32 by 32. Which we load that in somewhere. We could load that in here. I want to write this the right way. I could just hard code 32 and 32 here. I could just do that, but we should do it the correct way. I don't know. Okay. We'll just do that for now. I'm hard coding that right now for there, right there. Okay, so these are going to correspond. We'll have tiles 0, 1, 2, 3, 4, 5, unless it starts at 1, and I'm not sure if it does. It might. We might have to keep that in mind. Because 0 might just mean no tile is there. Then we might have 1, 2, 3. So we're going to have to offset stuff by 1 also. Where's my train of thought? So to find the correct number, tile width is 32. Okay. The other thing I need is total tiles per, or let's just say total columns. is equal to the tile set dimensions dot x divided by the tile width. So if this is 512 pixels wide, and we know that tiles are 32 pixels wide also, then we have 16 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So from there, if we know that's 16 columns, if we need to find like 145, we're going to have to go 16, 16 again, like to 32, 60, blah, 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 48, 62 and stuff. So I believe what I would do is take the image code, which we have, let's do 34. That should be relatively easy. We have an image code. If we divide it by the amount of columns, we get a 2. If we take an integer division, it's 2. And then if we do 34 mod 16, we get 2. So let's look at oops. Let's look at 2, 2. So 0, 1, 2, 0, 1, 2. I hope it's this one. I don't know. Like, I'm kind of mad now, so my brain isn't working as good as it should. This is the ceiling, so that it's possible. I don't know. 18, 18, 18, 18, 34, 34, 34. Okay, it should be this one, I think. Let's just calculate something and see what we get. I also forgot one more thing. We don't want the actual X and Y here because that's going to be 0, 1, 2, 3 because this is grid based. We need this to be multiplied by the width and height. So yay, we're hard coding some more numbers. There, now we have a lot of ceilings for some reason. I am not calculating this correct. So this, let's try times 32 because again we have that issue with the okay, that's not correct. Something else I should have put in here. If the image is 0 or nothing, we should just not store it. Ugh. Sorry, this is like kind of getting all blobby. Okay, since I'm editing this anyway, I'm going to change this up so that instead of like a tile-based XY, I'm going to have the pixel-based XY, because that's how I like it anyway. If I wanted to make a game where things aren't stuck on a grid, I could reuse this map format. So we're not going to use tile-based XY, we're going to use grid-based. We'll still use 0, 1, 2, 3, 4, 5, 6, 7 for Z though. Okay, at the moment now these are pixel based, so that simplifies that part at least. We still have a problem of trying to find the code, and I've done this before. We're closer. So right now, this is the off by 1 problem. We have this as the floor everywhere instead of that as the floor everywhere. So first, we are going to take the image code and subtract it by 1. So this minus 1. And now let's see what we get. There, now it's loading right. Okay. I had these also backwards. It helps to have those in the correct order. Okay, so let's open up room.moo. Let's see if that... It works! It does it! But I don't want to display the collision. So usually... we don't... I would kind of rather put that as properties, but... I'm just gonna store collision tiles and just keep that as collision information. So if it is, else if type is collision, we're gonna store this information in the collision tiles. Otherwise, we're gonna store it in the under tiles. Okay, the ceiling's not being displayed because I commented that out. We're going to need 2 separate draw functions because we're going to need to draw before and after. So draw below, or draw under, draw over. This will be under and draw over. And then in our game state, we'll have draw under, then we'll have a place to draw characters, so draw characters here, build, run, there we go. We have maps now. We did it. I didn't update the board, but maps, that's building the maps out. Map loading, tile object, map manager. I didn't write the map manager. I should have put those in different tasks. Done. We did it. Yay. I also did really basic game objects. So that's done. We have a game state, but it's not finished, but it's a game state. I mean, we'll continue working on it. I made a character enemy. Well, I made a character object. I made a map. We'll need to make more maps in the future. And it is Saturday, so we're gonna have a postmortem also. I did some main character art. I'm not done with it, but I did some. We'll make some more tickets for this. We did some environment art. And haven't done audio yet, so cool. Retrospective time. So, what did I do well? What did I not do well? Let's do plus, minus, or change or update. So, I spent a lot of time on art, so I kind of wish I would have given myself more time for art to kind of get all that done, because it's not really usable right now. But I did do a lot of environment art, and I did that stuff. I feel like I didn't split out tasks well enough. Let me make it smaller to thing. Like I put too many things in a task at a time, like the map manager plus map. So probably Monday I will work on changing tasks up a little bit and expanding stuff out. Just do some more planning for the next sprint. I did a lot of art. Like, I did enough art to really kind of I did enough environment art for this sprint and next sprint. So did a lot of environment art. What didn't go well? OBS recorded the wrong screen, the wrong window, when I was trying to animate my character, which was frustrating. And that caused me to not want to do any more game dev that day. I could have worked on the map stuff that day, but I got sad. So, double check that shit. Video capture as it's going. I think I did a good job of making videos, so I didn't do them every day, but I did them about every other day. Made videos regularly. They do take a lot of editing though, and I fell behind on doing the captions, so I need to do that maybe tomorrow. I'm still kind of working on figuring out how to format videos. And some are really short, and some are really long. I also don't know if they're a good educational resource the way I currently have them. Maybe they're just... like, if you're a complete beginner, it's not going to be helpful. Maybe you'll watch and, like, gain some things, but you're also going to be like, holy shit, what's going on? Maybe not great educational resource. But, you know, I can always make other resources, and I will be, because I think I'm going to be teaching a database class next semester. Did some animations, did some sprites, so that's good. I didn't finish the sprites. Didn't finish... or I guess I renamed her to Ida Sprite. Loaded maps. And I think that, like, I was planning on making basic objects, but I feel like I should have done this by feature instead of just, like, by object. So I don't, like, Audio Manager isn't really even that important until later. So we'll just put that under the planning stuff. I did enough coding. I did coding. I coded. Mostly I'm wondering about what to change for next sprint. And if you have any suggestions for what I should change for next sprint, which is next week, like, comment, and subscribe. No, I don't care. Don't do that. Honestly, I don't think I've ever said those words in any videos in the entire time I've had YouTube. But you can comment down below in the doobly-doo if you have any suggestions on what I should change for next sprint. I didn't really post any screenshots, or I posted like 2 screenshots or something to Patreon. I mostly just posted the videos early, so... But in a way, it's like a weird balance of, like, it takes a lot of time to make a game, but it also takes a lot of time to edit videos. And it's like, I don't want to over-encumber myself too much. Yeah. I think that's it. Like, I think that's okay. I know I had some thoughts about a retrospective like yesterday, but I forgot it. I should have kept notes. Keep retro notes. Because I'm gonna forget. Okay, well, I guess that's all I have. I'm gonna finish editing this video and get it posted up, and then I'm gonna go play some video games, or maybe I'll hang out with my husband and then play video games. We'll see. That sure was an exciting sprint, right? Did you enjoy watching the videos? I hope so. I'm probably gonna take Sunday off, and because today's Saturday, I'll take Sunday off, and then get back to work on Monday.